Hi, welcome back to our next level 1 geometry video. This could be our last video. I haven't decided if we're going to just have another 1 or 2 videos to wrap a few things up, but most likely at this stage it's going to be our last video, and this video is on equal tangents. Tangents which meet at the same point are equal in length. So let's explain and show you what the heck this is all about. So we've got our circle. Let's bring up a tangent. A tangent is a line that meets or touches a circle at one point. We're going to bring up a second tangent. So the first tangent touches the circle at point A, and the second tangent touches the circle at a point we're going to call B. Now, a lot of the time, not always, because if I moved around here, they may be parallel and therefore they won't touch. But a lot of the time, the tangents are going to meet at another point, and I'm going to call this point C. And the rule you've got to learn in this video is that the distance from B to C is the same distance from A to C. So tangents at a point are equal in length. Right, well, this creates a couple of scenarios we could look at. So let's look at our first scenario. If I was to draw a chord between A and B, you could see that I've created an isosceles triangle. So the distance from A to C is the same as B to C, so these two sides are the same, so it's an isosceles triangle. And so we have base angles which are equal in an isosceles triangle. And if you are asked to calculate this third angle, angle ACB, you just subtract 58 twice from 180. At a certain point, no doubt, if I was just to maneuver it a tiny bit further, we'd get to a point where it's 60, 60, and 60, which suggests that all three sides of this triangle are equal. So it's an equilateral triangle instead of an isosceles. All right, well, there's another scenario which might come up, and it could be this. If I was to draw a line from the center to point C, I'd create these two triangles and add in these two radii. And in this scenario, you need to know a couple of things. Well, the first thing is, remember, a radius and a tangent meet at 90. So we know straight away that one of these angles in the triangle is 90. And we'd also know that these two angles here are equal because these two sides are equal and our two radii are equal. So it's symmetrical. This line here is symmetrical down the middle. All right, well, let's go back and do a quick example to finish off this video. So, example 1, what kind of quadrilateral is the shape AOBC? AOBC is a quadrilateral with four sides, and we've got to determine what kind of shape it is. What kind of quadrilateral, I'm sorry. Well, the first thing to realize is length BC is equal to length AC, as we're talking in this video, and the rule we're going to say is equal tangents. Now, we know that length of BO is equal to AO because they are equal radii. So because we know BC and AC are the same and BO and AO are the same, what kind of quadrilateral is it? We don't know this angle in here. We don't know if it's 90 degrees with an angle BOA. We haven't got enough information if it's 90. If it was, it could be a rectangle or it could have been a square. But because we don't know that, we are going to assume it's not 90. So we're going to assume that the quadrilateral is indeed a kite. All right, thanks very much for watching and best of luck for your level 1 geometric reasoning exam.